This is Jason McIntosh with McIntosh Applied Engineering. In this video, I'm going to give you a brief overview of the Ares Acoustic System. When you first run Ares, it can be a little confusing as to what you need to do. Ares is composed of a number of modules. Each module acts as its own independent program, with each module providing an important function for an overall acoustic design strategy. In this version of Ares, there are 6 modules. In this video, I'll be briefly discussing 5 of them. The overall strategy behind Ares is captured in this slide. The modular is meant to be the central focus of Ares. The other modules funnel their information into the modular that allow you to complete your design. They're an acoustic flow impedance module, acoustic surface impedance module, speaker parameters, and a sound card-based frequency response measurement. Together, these are designed to help you achieve an acoustic design quickly and easily. Returning to Ares, to use Ares, you create a new module. For instance, here we'll just create a modular module. When you create a new module, under the Modules menu, there will be an entry for your new module. In this case, we created a modular module, and its default name is Module 1. We can rename this module to something more meaningful for us. For instance, let's name it Earpiece Design. Now when we go up to the Modules menu, this module is called Earpiece Design. You can create any number of instances of any of these modules. For instance, I can create a frequency response measurement. If we now pull down the Modules menu, we see that there are 2 modules present. The second one, with the default name of Module 2, is a frequency response measurement module. We can rename this to Earpiece Measurements. And when we go back to the Modules menu, it now has the name Earpiece Measurements. When you save an Ares file, all of the modules are saved to the one file, so that you can contain an entire design in one file. That one file can contain all of your frequency responses, any models you have associated with them, and all your impedance data. When you create a module, the menu changes to add items specific to that module. The Ares menu has 2 vertical pipes, between which will appear the custom menu items for that module. If I go back to the Earpiece Design module, the menu items between the 2 pipes change and now show the menu items for the modular. Now I can go to the acoustical menu, select speaker, and place a speaker into the model. To the far right on the Ares menu is the Help menu. When you pull it down, you'll see an About box. This About box tells you about what license you have and the version numbers for all the modules. The next item in the Help menu is a command that will cause the web page to open to the Ares instructional video page. When I select this, this web page appears. Resize it here. Which shows all the instructional videos for Ares. And eventually this video will appear in the list. These videos are meant to take some of the pain out of learning how to use Ares, so you don't have to go through all of the manuals. However, these videos are not a complete replacement for the manuals. You'll still want to refer to them for a lot more detail. Returning to Ares and pulling the Help menu down again, you will see that there are manuals for each of the modules, including an Ares overview manual, which will take you through the installation and registration process. As I indicated before, Ares consists of the modular and a series of measurement modules. The philosophy behind Ares is that you're going to use the modeler to create an initial model for your design. Once you have your initial design, you'll then create it in plastics using a 3D CAD program, such as SolidWorks. That 3D CAD model will then be printed with an SLA, which you'll use in conjunction with the frequency response module to verify your design. Once you get those measurements, you'll then correlate your measurement with the model. Correlating measurement with the model is an important step because you'll be making assumptions when you create your model that may not be entirely true for the plastics that you realize. Once you adjust your model to compensate for the realistic plastics you had to build, you can then use the model to help you take the next step in your design. This next step will consist of changing, modifying, and perhaps even adding to your model so that your frequency response will be closer to what you desire. Once you make those changes, you build another SLA and repeat the process until you finally converge to a design. This model and experimental approach is, in my experience, much quicker than if you just tried to create a complex model to achieve a final design, or if you just tried to stay in the lab and achieve a final design through experimentation. So let's now talk about the modules very briefly. Note that eventually there'll be a video for each one of these modules that you can refer to for more detail, but we'll just cover them quickly here. The coordinate mapper module lets you import an image and read coordinates off of it. This isn't really an acoustic specific module, but I found it to be extremely handy in a number of designs. The flow impedance measurement module measures the acoustic flow impedance through thin materials or structures whose thickness is much less than the wavelength of sound. These impedance measurements can be imported into the modeler module so that your modeler can use the exact impedance of your different acoustical structures. The surface impedance measurement module measures the impedance into a structure, such as the rear cavity of a speaker, the throat of a horn, or even your ear. Again, the impedance measurements from this module can also be imported into the modeler. The frequency response measurement module uses your computer's sound card to perform simple frequency response measurements. Finally, the modeler module is again the central focus of these tools. You will use the modeler module to create models of your design, and you will import data into the models so that you can verify your model through experiments. Finally, there's a speaker parameterization module, which is presently proprietary for May's use. That's the quick introduction into the Ares acoustic system. I suggest you see the other videos to get more information about the other modules. And if you have any questions, please feel free to contact us at support@maellc.com.